Spike testing, software testing. Spike testing is a type of software performance testing that is done by suddenly increasing or decreasing the load on the system or software application. The load is generated by a huge number of users and the behavior of the system is observed. The goal of spike testing is to determine whether the system will fail or survive in case of dramatic changes in load. Objectives of spike testing. Performance under stress, evaluating the system's response to a sudden and notable spike in the volume of transactions or users. Testing for scalability. It involves determining how well the system can dynamically scale resources to meet demand surges while preventing an unacceptably high degradation in performance. Response time. Monitoring the application's response time during periods of high load to make sure it stays within reasonable bounds and doesn't cause unacceptably long delays. Availability and reliability. Ensuring that there are no crashes or outages even during times of abrupt and high activity on the system. Failure recovery. Evaluating the system's ability to bounce back from a stress or load spike and return to a stable, functioning condition. Spike testing process. Test environment setup. Firstly, testing environment is set up to perform a successful test. It is set up to get a good quality testing process. Determine extreme load. After setting up the environment, the extreme load is found what a system can resist. Extreme load is the maximum number of users that can use the system or software application at the same time. Increase load to peak. Now the load on the system or software application is increased to the peak point. This process is performed abruptly, i.e., suddenly the load is increased, not gradually. Analysis on peak point. The behavior of system is observed under the load on the peak point. It is observed that whether the system crashes or survive under this sudden increased load. Decrease load to zero. From the extreme point, suddenly the load is decreased to zero or minimum load possible. This process is also performed abruptly, i.e., suddenly the load is decreased from peak value to minimum possible value. Analysis on minimum load. The behavior of system is observed under the minimum possible load. It is observed that whether the system crashes or survive under this sudden decreased load. Performance graph analysis. The performance graph of the system formed by abruptly increasing and decreasing the applying load is analyzed. It is observed that what kind of spike is formed. Spike testing tools. All the performance testing tools can be used to perform the spike testing, as the spike testing is a type of performance testing, but there are some specific tools that are commonly used in spike testing. The commonly used spike testing tools are 1. Roadrunner 2. Apache JMeter. Advantages of spike testing. Proactive issue identification. It detects possible resource shortages, scalability problems or bottlenecks before they affect consumers in a real-world scenario. Enhanced reliability. It reduces the possibility of crashes or downtime by making sure the program is dependable and accessible during times of high user activity. Optimizing resource allocation. This helps with effective infrastructure planning by offering insights into resource utilization patterns during peak loads. Disadvantages of spike testing. Limited predictability. It may be difficult to correctly predict sudden spikes, which makes it challenging to simulate real-world scenarios. Incomplete coverage. As the emphasis is on sudden, drastic changes rather than a continuous increase or reduction in load, spike testing may not cover all possible stress scenarios. Resource-intensive. To simulate many concurrent users or abrupt changes in workload, spike testing may need to be conducted, which can be expensive and resource-intensive. Conclusion. A useful performance testing called spike testing is used to evaluate how a program's software reacts to sudden and significant shifts in workload or system parameters. When implemented carefully, it enhances a system's overall durability and reliability by providing a proactive means of seeing and resolving such problems before they have an effect on end users in practical situations.